Hey, everybody. So we are looking at 11.4 part two today, looking at two other basically shortcuts to figuring out or proving triangles are similar. Before we get into this, though, a real quick want to have you guys try out a warm up dealing with what we were learning yesterday. Okay, this is asking, are the triangles similar? And if so, find X. All right, so just to kind of get your brain in the right spot, in the previous lesson, we learned I guess I call them shortcuts, but they're theorems. We learned a theorem to prove that two triangles were similar if they have two pairs of corresponding angles that are congruent. If you guys remember, it was called angle-angle similarity. All right, so just to kind of do the first part together, are the triangles similar? Well, I can see that, yeah, we do have two pairs of corresponding angles that are congruent, and that's enough information for us to say, yes, these two triangles are similar. All right. So yeah, we'll just go ahead and say yes, and let's give our reason because of angle similarity. Okay, but really what I want you to do is, now that we know that these triangles are similar, I want you to find x. Okay, remember that means creating a proportion, setting the ratio of two corresponding sides equal to the ratio of two other corresponding sides, cross multiplying and solving. Okay, so go ahead and copy this and make your proportion and solve for x. Okay, so on this problem, it's really, obvious what our corresponding sides are. This side would correspond to this one, and this side here would correspond to this one. Okay, so that's what I'm going to make my ratio of. I'm going to start with these sides because I like to start with whichever corresponding sides has my variable. Okay, and just a reminder, when you make these ratios, I highly recommend always going left over right. So I'm going to do x over 8 for my first ratio. And then for my second one, 25 over 15. Okay, and I just want to kind of point out again, I could do 8 over x as my first ratio. But if I did right over left, I would have to do right over left for my other one. I would have to do 15 over 25. Okay, so it's not that you always need to do left over right, but it's good to just kind of decide in your head what your pattern is and stick with it. Okay, because it's easy to kind of mix them up. Okay, so here's what we got. I can cross multiply and solve, but what I notice is I've got a fraction here. I know I can reduce this thing really easily by a 5. So I'm actually really quickly going to go one more step here. And before I cross multiply, I'm going to divide 5 into both of these. So 5 goes into 25 5 times and 15 3 times. Okay, I just want to point out this is an unnecessary step that I just did, but it's so quick and easy to reduce them that when it looks easy, I like to do it. Okay, so 3 times x gives me a 3x, and 5 times 8 gives me a 40. Okay, and then solving for x, dividing both sides by 3. Let me scroll this down a little bit. Okay, looks like we're getting x equals 40 divided by 3. This is not going to divide evenly, but that's okay. I still want us to divide it, whether it gives us a fraction or a decimal. So it looks like I'm getting 13.333, and it repeats. And I just want to point out again, because I always have people wonder how to do this. In this class, we'll normally round to the 10th spot, one decimal place, this thing right here. Okay, the question is does this stay a 3 or does it round out to a 4? Okay, and it's all dependent on the number next to it. If this is a 5 or more, it would round this thing up to a 4. But since it's not, this 3 is going to stay a 3. So we'd write this as 13.3. Okay, and there it is. All right. Something I haven't mentioned in a little while, but always whenever you get a side length to a triangle or even an angle, check to see if it makes sense. Does it make sense for this side length here to be 13.3 if this one over here is 8? Okay, the numbers here are kind of weird. I guess to point out, these triangles actually don't look like they're drawn to scale. They're saying this is 15 and this is 8. Okay, so these are kind of warped, weird triangles. So yeah, maybe just looking at it doesn't make sense, but comparing corresponding sides does. If this one's 8 and this one's 13.3, yeah, that makes sense if this one's 15 and this one's 25. Okay, so just a little reminder, it's not a bad idea to just check your answer in the context of your problem. Okay, so here's the big thing today. We're looking at what's called side, and side angle side similarity. Okay, and also here, is the angle-angle similarity. So let's see, I guess I can fit all this on one slide. All right, go ahead and get the title. I would suggest getting angle-angle similarity, even though this is what we learned last section. It'd be nice to have all three of our rules all in the same spot. And these are the only three rules we're learning when it comes to triangle similarity, because they're the only ones that exist. Okay, so go ahead, take a couple minutes, get the title here, don't forget the part 2, and get these three triangle similarity theorems. Okay, so I'm not going to spend too much time on this one. We just looked at angle-angle similarity. This is probably the most straightforward of the three. Two pairs of corresponding angles congruent, boom, you have similar triangles. Okay, the new one, I'm going to start with this one, side-side-side similarity. Okay, here's the thing. This is a little different from when we did side-side-side congruency. On this one, to use side-side-side similarity, we have to check to see if the ratios of the corresponding sides are equal. We've done this in the past, okay? But that's all we need to check. We just need to check if all of those corresponding sides, if you wanted to color code them in your notes, it wouldn't be a terrible idea, okay? But yeah, AB over DE, BC over DF, and BC over EF. Okay, if all of those ratios are equal, then that's enough for us to just say, all right, they are similar triangles. Okay, on this one, side angle side, it's a similar idea. We have to have two sides in an angle, and when it comes to the angles, they just need to be congruent. Okay, and when it comes to the side lengths, yeah, just like the other ones, they need to be proportional. The ratios of those corresponding sides. Again, if you want to highlight them in colors in your notes, it's never a bad idea. AB over DF, okay, AC over DF. All right, here's the big thing I want to remind you of. For us to use side angle side similarity, that angle must be between the two side lengths. Okay, notice how this angle is between the sides. Okay, I just want to point out, say instead of this angle being the congruent one, say they told us that it was this one and this one. Okay, this would not be using side angle side similarity. Really, if we went around the triangle, it'd be side side angle or angle side side, which is not one of our rules. Okay, so just be careful on this one. That angle needs to be between the two sides. Okay, cool. So yeah, our focus on this lesson is these two. So let's go ahead and try some out. Okay, so go ahead, take a minute, copy both of these examples here. Maybe we'll call this one number 1, this one number 2. Okay, we'll do these together. All right, so it's saying show why the triangles are similar. Okay, they're telling us they're similar, and they want us to show why that's actually true. All right, well, here's the thing. On number 1 here, I can see that I have side angle side on both of these triangles. Okay, this is using side angle side similarity, but I want to show why it actually is. So I guess maybe the first thing to point out is, let's just point out, okay, side angle side. Okay, and maybe let's say similarity, not to get it confused with side angle side congruency. Okay, so that's what it's using, but why do we know that it's using it? Okay, well, let's show, first things first, let's go ahead and show that that angle is congruent to itself. All right, or sorry, angle R is congruent to angle N. Those corresponding angles are congruent, is what I meant to say. So angle R is congruent to angle N. Okay, that's one thing that's important. Okay, the other thing we need to show is that the ratios of these corresponding sides are equal to one another. All right, so let's go ahead and write them out. I'm going to start with this one, 24 over its corresponding side, 18, okay, is equal to this 28 over its corresponding side, 21. All right, and to show those are actually equal, we need to reduce these fractions and actually, show that we're getting the same number. All right, so 24 over 18, I'm thinking what's the biggest number that goes into both of those? When in doubt, if they're both even, 2 goes into them. Like, just to kind of show you, at the very least, 2 goes into 24 12 times and 18 9 times. Okay, but a 12 over 9 would then reduce even farther, right? I know that 3 goes into 12 4 times and 9 3 times. All right, so really a 6 was the biggest number. If we could have realized 6, we would have gotten 4 over 3 immediately. But I just wanted to kind of show you, just when in doubt, pick a number you know goes into both of them. Even if it's not the biggest number, you just might need to reduce even farther. Okay. Okay, so yeah, this reduces to a 4/3, and I'm taking a look at this one. I'm thinking 7 goes into both of these, right? 7 goes into 28 4 times and 21 3 times. Okay, so this is us showing that, yeah, we have, side angle side, those ratios of the corresponding sides are in fact equal, and those corresponding angles are in fact equal. Okay, all right, number 2 is the same idea. First things first, I'm noticing on these two triangles, the information that they're giving us is just sides, all right? So I know since these are similar, this thing is using side, side, side similarity. Let's start with that. Okay, now I need to show why side, side, side similarity is actually what's being used. I need to make those ratios of those corresponding sides. Here's the thing that's a little tricky on this problem. It's kind of tough to tell what sides correspond to what. So this is where this similarity statement is nice to have. Let's number off these vertices real quick. Okay, so x, z, w. X is 1, z is 2, w is 3. Okay, over on this triangle, y, z, x. Y is 1, z is 2, x is 3. Okay, so just to kind of really make it plain to see, these are the two triangles we're looking at. This one and this one. Okay, so yeah, if you didn't realize that, it's kind of tough because we could also have possibly been using the whole entire triangle, but we're not. Okay, so let's go ahead and make our ratios of our sides. On the left triangle here, let's go ahead and start with the side length that's between 1 and 2, this one right here. Okay, so that corresponds to this side length between 1 and 2. So a 12/9 is going to be my first ratio. Okay, and since these are similar, they already told us they're similar. I know that's going to be equal to the ratio of two others. Let's go ahead and move on to this side length between 2 and 3. And I know it corresponds to this one between 2 and 3. So a 16/12. Yeah, sorry. For some reason, I got thrown off there. Okay, and then the last pair of corresponding sides, this one between 1 and 3 corresponds to this one between 1 and 3, so a 20/15. Okay, so on this problem, numbering off those vertices was very, very helpful because it's really tricky to kind of figure out what corresponds to what. Okay, so yeah, these should reduce down to the same number. Let's show that they actually do. So 12/9, I'm thinking a 3 goes into both of these. 3 goes into 12 4 times and 9 3 times. 16/12, a 4 goes into both of these. 4 goes into 16 4 times and 12 3 times. And then 5 goes into a 20/15 4 times and 3 times. Okay, so just by the way, they just so happen to reduce both down to a 4/3. That's not always going to happen, right? Okay, but this is us showing it. All right, so yeah, and something I always like to do, maybe should put a little check mark. That's how we know these are similar. On this one, this and this checks off. That's how we know these are similar. Okay, so yeah, I'm gonna have you guys go ahead and try one of these. This one is a little different. This one is asking, are the triangles similar? Are they similar? If so, show how. Okay, so you need to figure out, okay, which one of these theorems is being used, and figure out, if it's actually being used. All right. So before you guys get into it, I just want to point out something, a little reminder. Right now on these two triangles, we only have two sides on this one and two sides on this one. Okay, two sides is not enough information. It does not, none of our three theorems here uses just two sides. Okay, but can we find some more information on our own? Okay, well, yeah, if you guys notice, these two straight lines crossing right here create vertical angles. And we know as a fact, vertical angles are congruent to one another. Okay, so now we have enough information for you to figure out which one is being used. Okay, make sure you show me that the side lengths are proportional. Make sure you're making those ratios. All right, I'm going to leave this to you, so go ahead and try it out. Okay, so here's my first thing. I'm thinking, okay, side angle side. Both of these triangles have that information. All right, so this is potentially using side angle side, but to be able to be sure, we need to show that these ratios of corresponding sides are equal. I guess the first thing we should point out is that these angles are congruent. All right, and by the way, we showed that on our picture. That for me is enough information. We don't need to see or say triangle ACB is congruent to ECD. That's fine. These angles are congruent. The side lengths, that's what we need to check. Okay, so let's start with this side length here, 9, and its corresponding side on the other one. Be careful, these are kind of flip-flopped. Its corresponding side would be this one, right? Okay, so a 9/15 is going to be my first ratio. Okay, and I'm wondering, is that equal to the ratio of these other pair of corresponding sides, 18/30? All right, and that's why I put a little question mark there just to show yourself, oh yeah, that's what I'm wondering. Are these actually going to be equal? All right, and now that we have these ratios, we can see that this one's doubling this one. Okay, they're going to reduce down to the same number, but let's actually show that they do. Okay, I know that 3 goes into a 9 and a 15. 3 goes into a 9 3 times, and 15 5 times. Okay, and 6 goes into both of these. 6 goes into 18 3 times, and 30 5 times. All right, so they do check off. So we do have side angle side here. So now we can finally give our answer. Are the triangles similar? First of all, yes. Okay, and if so, the reason why? Side angle side similarity. All right, so just something you all probably have already noticed, the math we're doing is not any different than what we've done in the past. All right, but we're actually needing to do just less of it. All right, we're not having to list out all of the angles being congruent and showing the ratio of all of the side lengths being equal. Okay, we're using our shortcuts now. That's the nice thing about this lesson. Okay, so for this next one, I just want you to take a look at this problem and yeah, think about it. All right. Here's what it says. If possible, determine whether the given triangles are similar. Justify your answer. Okay, so go ahead. Take a look at these two triangles. All right. I've highlighted, the corresponding sides. If you want to jot this down on your paper, you can. But think about, okay, making a ratio of the corresponding sides. Okay, it looks like we have a pair of corresponding angles congruent. Is this enough information for us to determine if these triangles are similar? What do you think? Okay, so I'm thinking on these triangles, I have two sides and an angle on both of them. So my first thought is, okay, I'm potentially doing side angle side on these. Okay, and if I were to make a ratio of these side lengths, I could probably do this in my head. A 6/3, does that equal a 10/5? Yeah, these are going to reduce down to a 2/1. Okay, so that does work. Can I say these are using side angle side? No. Okay, and the reason why is because these congruent angles are not between the two side lengths. Okay, remember that is a necessary thing. We would need to have this angle congruent to this angle for us to be able to say, yes, these are using side angle side. Okay, so it's really close, but it's not quite right, and it's not enough information for us to say that these are. Okay, so if possible, determine whether the triangles are similar. I'm going to say cannot be determined. Okay, so that's kind of the idea of those. I just really wanted to point out side angle side. You got to have that angle between the sides. Okay, so let's try one more of these where we have some strange overlapping triangles. Go ahead and get this problem. We'll do it together. Okay, so it's telling us that we have similar triangles. Okay, so that's not even a question. We are told they are similar. Okay, find RT. All right, so let's first point out what they want us to find. They want us to find this, RT, this entire side length. Okay, this whole thing right here. Okay, so to find, missing side lengths, we're going to make a proportion just like we always do. All right, so here's kind of the thing about it. RT, this entire side length, we can call X. All right, so this whole thing is called X, even though they're overlapping one another. If I were to draw these separately, and sometimes it's not a bad idea, this would be the 10, 8 triangle, and then this would be the one with 12, this is what we're looking for. Okay, they're similar triangles. You know that this makes it a lot more obvious. Okay, when I go to write my proportion here, I'm going to be doing 10 over x as one of my ratios and setting it equal to, you know, the ratio of these corresponding sides, 8 over 12. Okay, so the overlapping triangles makes it a little tricky. Okay, but since we're looking for RT, yeah, we can call that whole side length x. Okay, from here, we can go ahead and just cross multiply and solve. I noticed we could reduce an 8 over 12. Okay, but on this one, I'm going to choose not to. I'm just going to go ahead and cross multiply. 8 times x is 8x. 10 times 12 is 120. Okay, divide both sides by 8. Looks like x is going to be, let's see, 120 divided by 8 gives me a clean 15. Okay. And, you know, just to kind of check, does it make sense for this side length to be 15? You know, if this is 10, this is 8, this is 12, yeah, that looks right. Okay. All right. So with this in mind, I want to kind of look at a question that asks us a little bit something different. I guess just real quick, for example, what if instead of RT, what if they asked us to find just ST? What if they just wanted us to find this little thing right here? Okay, what would we do? All right, that's what the next question is going to kind of get into. Okay, so this is just a discussion. You don't need, I do want you to copy this. So go ahead and just copy this part right here. Okay, but here's the thing. This is saying when asked to solve for y, a student set up a proportion as shown. So a student made this proportion. Explain why the proportion is wrong. Okay, how should you adjust the proportion so that it will give you the correct results? So this right here is wrong. Okay, and let's just kind of point out what's going on here. Here's what the person did. They said, okay, I'm going to make a ratio of y over 8 and set it equal to 14 over 10. Okay, that's what they did here. Here's a part that is right about this. 14 over 10, yeah, those are corresponding sides. This ratio right here is wonderful. Okay, here's the question. What is wrong with y over 8? Why can't I make a ratio of y over 8? It looks like, you know, those are also kind of, you know, sort of corresponding parts. Okay, well, here's the problem. Y is not a side length. Okay, if you guys take a look, 8 is the side length, the entire side length of this triangle. Okay, that number is good. Y, though, is not the side length of this big triangle. All right, it is just a piece of the side length. Okay, the entire side length of this triangle is this thing, right? It's this whole thing. Well, how do we represent that when it's, you know, two different things? We just add them. Okay, so this side length here can be represented as y plus 8. Okay, so this is wrong. You know, maybe in your notes, just really show yourself that this is wrong, this proportion, and let's show what the right one would look like. Okay, this side length here would be y plus 8. Okay, over the corresponding side of this triangle, which is still 8. That's still looking good. Okay, okay, which is equal to the ratio of these corresponding sides, which again, that worked, 14 over 10. That looks good. Okay, so yeah, this is a really, I guess, tricky thing. This is you can run into this problem. So in your notes, go ahead and show that this is the correct way. Okay, which by the way, they didn't ask us, but let's actually go one more step. Let's solve this thing for y. Let's do it. Okay, let's go ahead and cross multiply. So this is going to be a 10 times the y plus 8. Okay, when I write this, I need to write it like this. 10 is being multiplied by all of y plus 8, so I need to put that in parentheses. Okay, over on the other side, we have 14 times 8. All right, I'm just going to do that math in my calculator, and it looks like I'm getting 112. Okay, from here, you know, we're going to distribute the 10. So 10 times y is a 10y, 10 times 8 is 80. Over on the right, we have that 112. All right, and then just two-step equation, right? Subtract 80, divide by 10. Okay, so I'm getting 10y equals 112 minus 80 gives me 32. and then dividing by 10. Okay, looks like we're going to get a decimal on this. 32 divided by 10 is going to give me 3.2, which there's no more numbers, so there's no need to figure out where it's going to round to. It's just a 3.2. Okay, so yeah, when you guys get to your assignment on this, look out for problems with these overlapping triangles. If it's like the last one, where they're asking us just to find the entire side length of a triangle, that's okay. You can represent that entire side length as just x. That's fine. Okay, but if they ask for just a piece of a side length, okay, we cannot just use, y over 8. We got to use the entire side length when we make our proportions. Okay? All right, guys, cool. So that's that for this lesson. I'll see you guys. Bye.